So these are the notes for section 16.4. We continue to look at conic sections. And these are the notes on ellipses. Our goal today is to be able to graph and write equations of ellipses. What we're going to find out is that the pattern that we follow looking at parabolas and circles is going to follow today. There's going to be a standard form. Some of the aspects of the ellipse as we graph it we'll be able to determine from the equation itself, and that'll allow us to go to the coordinate plane and sketch a graph. And we also can write equations if we know a little bit of information about some of the points on the graph of the ellipse itself. So an ellipse, it looks like a stretched out or flattened out circle. All points P in a plane such that the sum of the differences between P and two fixed points called foci is a constant. And if you could imagine taking a string and tacking it down at the two foci and then wrapping that string around your pencil, if you drag the pencil around as far, stretching tight the string, this is the shape that you would get, an ellipse. So obviously the ellipse is longer than it is tall, or you can have one that's taller than it is wide. But one of the axes will be lengthier than the other. We're going to call that our major axis. The other is the minor axis. The points where the minor axis intersects an axis, those are known as the co-vertex. Where the major axis intersects the ellipse, that's known as the vertex, and those foci are a certain distance away from the center, which we're going to find out about in a little bit. So for our purposes today, as we've had in the past with the rest of our conic sections, we're going to only consider ellipses that have their center at the origin. A little bit later on in your math careers, you'll deal with what the equation looks like if the center were not at the origin, but we're not going to concern ourselves with that right now. Standard equation of an ellipse when the center is at the origin, at 0, 0. If the major axis is horizontal, so longer than it is tall, it'll look like this: x squared over a squared plus y squared over b squared equal to 1. Major axis horizontal. The vertices, where the ellipse intersects the major axis, is positive a, 0, and negative a, 0. So the same distance away from the origin. The co-vertices, the minor axis, 0, comma b, 0, comma negative b. If it looks the other way, taller than it is wide, x squared over b squared plus y squared over a squared equals 1. So now our major axis is vertical. The vertices are at 0, comma positive a, 0, comma negative a. So those are going to be on the y-axis. The co-vertices, the short way, those are on the x-axis. B, comma 0, negative b, comma 0. A couple of things to point out here. How do I keep straight if it's x over a and y over b, or x over b and y over a? Here's the deal. A, always greater than b. So a is always going to be your major axis. If a goes with x, it's horizontal. If a goes with y, it's vertical. The other important thing to keep in mind is that the equation of the ellipse is always equal to 1. So sometimes when we have to put it in standard form, we have to divide through all three terms in order to get 1 on the right side of the equal sign. So A is half the length of the major axis, B is half the length of the minor axis, so the major axis itself will be 2 times A, minor axis 2 times B. And we talked about the foci, the focus. There's 2 of them. They're equidistant from the center, and we find that by plugging in c squared equals a squared minus b squared. So once we have our a and b from the equation, we can plug those in, c squared equals a squared minus b squared, and get a value for c. So let's take a look. So we're going to try to go ahead and graph an ellipse. And somewhat similar to when we graphed circles, we're going to identify 4 points that are on this ellipse. We're also going to locate the foci, and then we'll sketch in what the ellipse should look like. So let's start by putting this equation into standard form. I have 4x squared plus 25y squared equals 100. This 100, I want that to be equal to 1. So let's write it this way. 4x squared over 100 plus 25y squared over 100 equals 100 over 100. Now let's reduce. 25 over 100, 4 over 100, that's 25. So x squared over 25, 25 divided by 100 is 4. Y squared over 4 equals 1. So now it's written in standard form. We're asked to identify the vertices, the co-vertices, and the foci of the ellipse. So let's start with the vertices. Where are those going to be? Well, the vertices, remember, those are the endpoints of the major axis. A is greater than B here, always. And the greater number, 25, goes with x. So I know that this is a horizontal ellipse. It's going to be longer than it is tall. So I take the square root of 25 and I find that A is 5. So if that's the case, 1, 2, 3, 4, 5, I'm going to have one vertex at the point 5, 0. Going the other way, 1, 2, 3, 4, 5, I'm going to have a vertex at negative 5, 0. Now I'm asked to identify the co-vertices. That's going to be the minor axis. And so now I can see that 4 is B. So then B will be equal to 2. So now I've got these points. The last thing I need to find are the foci. And this is where I use c squared equals b squared minus a squared. Check myself for a second. A squared minus b squared. A is going to be larger, right? So a squared, that's 25. B squared is 4. So c squared equals 21. C is the square root of 21. Forgot to indicate the co-vertices at 0, 2, and 0, negative 2. So our foci, c equals square root 21. So one focus is at square root 21, comma 0, where square root 21 is going to be a little under, around 4.5. And then negative square root 21, 0. So those are going to be my foci. What's the ellipse going to look like? Well, just like we did with the circle, let's go ahead and draw in our smooth curve at where the points intersect the axes. And fill in the remainder. So it's going to look something like that. Here's the point 0, negative 2, 0, 2, 5, 0, negative 5, 0, and the foci, that's negative square root 21, 0, and square root 21, 0. So that's the basic process for sketching a quick graph of an ellipse. How about we go the other way? Can we write an equation of an ellipse if we're given some information such as the location of a vertex, a co-vertex, and a center? It helps to sketch it out. I'm given a vertex at 0, 4, and a co-vertex at negative 3, 0. So I can see that this graph is taller than it is wide. So this is vertical. Well, so what? What that tells me is that my A is going to go with Y. So I know I'm going to have x squared over something plus y squared over something equals 1. Well, what's my A value? Okay, that's the distance from the center to one of my vertices. That distance is 4, So y squared over 4 squared. From the center to the co-vertex was 3. That's my b value. So b squared is 3. X squared over b squared, y squared over a squared equals 1. So now I have x squared over 9 plus y squared over 16 equals 1. So go ahead and take a look at these. Take a look at the work that I'm going to ask you to do in class. Refer back to this video and to your own notes as often as you need.